So now we're being introduced to a new concept of how to compute the arc length. So we're given these two formulas over here. The arc length is equal to, from the integral from xl to xr of 1 plus f prime x squared times dx. And the second formula is y bottom to y top of 1 plus f prime y squared times dy. In a region bounded from x equals 1 to x equals 7, and we're given a term of y is equal to 1/3 x squared plus 2 raised to 3/2. So basically the arc length is, we're computing arc length, but we can do it with two ways, with respect to x and with respect to y. So when we do this with respect to x, it looks something like this. So we have our x limits, our xl and xr. xl is for left x, xr is for right x. So we have a line that looks like this, bounded between these constraints. And then over here similarly, but this is with respect to y, we have our y limits, y top and y bottom. And we have a line that looks like this, which is vertical. And we have our constraints, our y bounds. So keep in mind that on the left, if you see a function that has x limits, this will be in terms of x. If you have a function that has y limits, it'll be in terms of y, f of y. First thing we're going to do is we're going to identify the variables of integration, because the formula, we need f prime x squared. So our y is equal to f of x, and our f of x was equal to 1/3 x squared plus 2 raised to 3/2, as stated in the problem statement. So we have to take the derivative of this. So how do we go about this? Well, let's apply the chain rule. I think it's the easiest way to do this one. So f prime x, so our f, recall from the, if you don't know how to do the chain rule, I do have a video on that and I highly recommend you watch it. So anyways, the chain rule of a single variable function, we have f, g, f prime, and g prime. Let's set these up. So our chain rule is 1/3. The inside term we're going to call u raised to 3/2. The derivative of this would be 3/2 times the constant of 1/3 raised to u raised to 3/2 minus 1 is 1/2. And we see that these threes will cancel each other out. For our g is the inside term, so our g is equal to u, which is x squared plus 2. Thus our g prime, when we take the derivative with respect to x, it is simply equal to 2x. And the chain rule is f prime times g prime. So our f prime is 1/2 times 2x, which is our g prime, times u to the 1/2. And we see that those 2's will cancel out. So we're left with f prime x is equal to x, and our u is out, what was our g right here, where my mouse is x squared plus 2 raised to the 1/2. So that's our f prime. So now we need to square this. So f prime x squared is equal to x times x squared to the 1/2. And we're squaring both of these. Notice I use parentheses so we don't make a mistake when we square this. And I highly recommend you do it, so it helps you keep track of your work. So our f prime x squared is equal to x squared times the x squared plus 2 squared, which is simply just x squared plus 2, because 2 times 1/2 when we distribute the square is 1. So again, we're going to simplify this a step further. F prime x squared is equal to, we're going to distribute the x squared to both terms, which would be x to the 4th power plus 2x squared. So now for step 2, we're going to identify the limits of integration. So these were easy because they were given to us already. So the limit variables I use for my naming convention are these right here. So yt is top y limit, yb is bottom y limit, xr is right limit x, xl is left limit x. You can use whatever naming convention you want, it doesn't really matter. I use this because it helps me keep track of what they mean. Some people use A, B, C, D, it does not matter at all. Just know this is what I use. So in this case, we're given x limits. So that's how we know we have to have terms of x. So xl is equal to 1. Our lower x limit, our left x limit, and our right x limit was given to us as 7. So now for step 3, we're going to set up the integral. So we know the length, the arc length, is equal to the lower x limit raised to the upper x limit is 1 plus f prime x squared times dx. So now all we have to do is plug everything in, and recall that our f prime x squared was equal to x to the 4th plus 2x squared. So we're going to plug everything in, and we get, when we plug in everything, we get the limit, the integral is the limit from 1 to 7 of 1 plus x to the 4th plus 2x squared times dx. And what we're going to do this is, we're going to integrate this. This looks kind of complicated, but not really, and I'm going to show you why. So we're going to integrate this. So the integral is very hard because u substitution does not work here. So how do we take this integral? So again, the integral, we're going to write this in descending order as x plus 4 plus 2x squared plus 1 times dx. So how could we take this? Well, as it turns out, this actually has a geometric property form. So we know a plus b squared, when we take the root of this, is a squared plus 2ab plus b squared. We know this because this is geometric property of the quadratic polynomials. So in this case, this is why I write it out in descending order. So that way we can see that x to the 4th is our a squared and 1 is our b squared. So what we want to do ideally is we want to identify a and b. So a squared is x to the 4th power. So we know a would be x squared because we're taking the square root of a to get a. And we know b, the square root of 1, is 1. So we can write a plus b squared as x squared plus 1 squared. So the arc length of this is bounded from 1 to 7 of x squared plus 1 raised to the square with respect to dx. So one thing I do want you to notice now, the arc length is x squared plus 1 squared times dx. And notice how the square root and the radical and the square will cancel each other out. So now the arc length became a whole lot easier, as now it's just bounded from 1 to 7 of x squared plus 1 times dx. So I'm going to plug in the balance and solve. So first, when we integrate the function, we get x squared plus 1. The integral of that would be, the integral of x squared is x cubed over 3. The integral of 1 is x, bounded from 1 to 7. So the first thing I'm going to do is I'm going to try to have a common denominator just because it makes it easier once I plug in. Of course, you can go straight into plug in, but I like to do this, and I highly recommend you do it. It makes it easier. So now we can factor out the 1 over 3. Now we just have one line. We have x cubed plus 3x, bounded from 7 to 1. So now when we plug this in, we get 1 over 3, and now we're going to plug in. So we get 7 cubed plus 3 times 7 minus 1 cubed plus 3 times 1. And we're going to simplify this. So we get 1 cubed, 7 cubed is 343, plus 21 would be 364. 1 cubed is 1, plus 3 times 1 is 4. So it's going to be minus 4 when we evaluate it. Thus, 1/3 times 360 minus 4 is 364 minus 4 is 360. Thus, our L is equal to 360 divided by 3, which is equal to 120. Now let's move on to a different example. In this example, we're given a region bounded by the first quadrant, y equals 0, y equals 2, and x equals y cubed. So one thing I do want you to notice is that we are instructed to set up the arc length integration, but we are instructed not to solve it. Why is that? You'll find out. But basically, sometimes some problems, they'll be set up do not solve type problems. So without further ado, the first thing we're going to do is identify the variables of integration. So we need the f prime x squared. So we know fy. Why am I using fy and not fx? Because we're given y bounds. We're given the limits in terms of y, so we're going to use y. So f of y is equal to x, which is equal to y cubed. Thus f prime y is equal to 3y squared. Thus f prime y squared, when we square, is equal to 3y squared raised to the square power. So we're going to square each term individually, and we get 9y to the 4th power. Step 2, we're going to find the limits of integration. And the limits of integration were already given to us in the region bounded by, again, these are the naming convention I use for my limit variables. And the bottom y is equal to 0. The top y is given to us as y top is equal to 2. So for step 3, we're going to set up the integral. So the integral is set up by this formula, the arc length of the bottom y raised to the top y of 1 plus f prime y squared dy. So the length is from the bottom y, so from 0 to 2, 1 plus the f prime y squared, we computed it to be 9y to the 4th power times dy. And that's the answer, because we were asked to set this up and not solve it. Why? Well, this problem can actually not be solved. This integral is unsolvable. I mean, you can try to solve it, but you probably won't be able to solve it. But yeah, that's pretty much it. Thanks for watching this example, but let's move on to another one. For this example, we're asked to find the region bounded from 0 to x, where x is greater than or equal to 0 and less than or equal to 4, and y is equal to 7 plus 8x raised to the 3 halves. So the first thing we're going to do, as we normally do, is identify the variables of integration. So we know our y is equal to f of x. So we need to find f of x. F of x is 7 plus 8x raised to the 3 halves. And we're trying to find the derivative of this, and then we're going to square it. So f prime of x, the derivative of 7 is equal to 0. The derivative of 8x to the 3 halves is 3 over 2 times the constant of 8 times x, and 3 halves minus 1 is to the 1 half. You can apply the chain rule, you'll get the same answer. Or you can apply the power rule, that's what I applied. And f prime x squared, so now we're going to simplify this first. So f prime is equal to 8 times 3 divided by 2 is 24 over 2, which is 12, times x to the 1 half. And f prime x squared, when we square each term, we get 12x to the 1 half squared, which is equal to 144. 12 squared is 144, x to the 1 half squared is 2 times 1 half, those cancel, so we're left with just x to the 1 power, or simply x. So now we're going to find the limits of integration. The limits of integration were given to us. Again, these are the limit variables that I use, and in this case the left x was equal to 0, and the right x is equal to 4, as given to us in the problem, because we're computing the arc length bounded by the region of x is greater than 0, less than 4. And now we're going to set up the integral. So we know the formula for the arc length with respect to x is xl to xr, bounded from xl to xr, of 1 plus f prime x squared times dx. And we know f prime x squared, as we computed it, was equal to 144x. So now we're going to set it up. So it's 1 plus 144x times dx. So now we're going to integrate this function. So what method would work here? Well, as it turns out, the best method would be to apply u substitution, which is what we're going to do. So we're going to set up u is equal to 1 plus 144x, du is equal to 144 times dx, because we're only taking the derivative with respect to x, so the derivative of 1 is 0, the derivative of 144x is 144, and thus when we solve this for dx, this is equal to du divided by 144. And now this next step is a key step that you're probably not familiar with, so I do want you to pay attention right here. So since we applied u substitution, as I did mention in the instructional to this video, our limits are going to change. So the next step is to plug in the current limits into u to get our new limits. So what are current limits? Our current limits are xl is equal to 0 and xr is equal to 4. So we're going to plug these into u as a function of x so we can get new limits. So thus, u of 0 is equal to 1 plus 144 times 0, which is simply equal to 144 times 0, 0, so this is simply equal to 1. Our left x limit and our right x limit, u of 4 is equal to 1 plus 144 times 4. So this is equal to 144 times 4 is 288 times 2 is equal to 577. You can use your calculator. So these are our new limits. So do not miss this step because you're probably not familiar with this step. So now let's integrate with respect to u. So now we're going to set up our new integral and solve it. So keep in mind now we're going to substitute, since we applied u substitution, we're going to substitute the u and the dx back into the formula. And if you're not comfortable with u substitution, I do have a video on it in this Cal 2 playlist, so feel free to watch it. So that's our arc length is, our new limit is from 1 to 577 of u square root of u of du divided by 144. So we're going to pull out the constant of 1 over 144. And we're going to rewrite the u to the square root as u to the 1/2 times du. So now we're going to integrate this function applying the power rule. So 1 over 144 of the integral of u to the 1/2 is u raised to 3/2 divided by 3/2, which is, when we reciprocate it, it's 2/3, bounded from 1 to 577. Thus our L is equal to, when we simplify the constant, 2 divided by 144 times 3 can simplify to 1 over 216. You can use your calculator for this. And then u to the 3/2 bounded from 1 to 577. So now what I'm going to do is I'm going to simplify this. So 577 raised to the 3/2 minus 1 raised to the 3/2. And notice how I did not plug in u back in. Why? That's because I changed the bounds of integration. Since I changed the boundaries of integration, you do not plug in u. That's the whole purpose of creating new bounds of integration. So you don't not plug in u again. Instead, you plug in your new limits. Because these are your u limits. These aren't your x limits. These are considered your u limits now. So you simplify this. We get L is equal to 577 raised to 3/2 minus 1, because 1 to 3/2 is 1, divided by 216. And that's as far as I took it. You could compute it in your calculator. I'm not going to, because I think this is actually a better way of presenting your answer. So let's move on to the next problem. So in this problem, again, we're given a setup do not solve type problem. And we're given a region bounded from 0 to 1, from y is greater than 0, less than 1, and x is equal to 4/3, 5y squared plus 8 raised to 3/2. So step 1, we're going to identify the variables of integration. And again, keep in mind this is just setting up the arc length integration, it's not solving it. So our f of y is equal to x. And our x, as we can see, is equal to 4/3, 5y squared plus 8 to 3/2 where my mouse is. So that's our f of y is equal to 4/3, 5y squared plus 8 raised to 3/2. So now the first thing we're going to do is we're going to find the variables of integration. So we know from the formula that we have to find the derivative and then we have to square it. So first thing we're doing is we're going to find f prime y. And we're going to do this applying the chain rule, as we've done already. So we're going to set up our f prime, our g prime, and our f and g. So we know our f is 4/3. The inner term we're going to call u raised to 3/2. And when we take the derivative of this, we multiply. We bring the exponent to the front, so it's 3/2 times the current constant, which is 4/3, times u, raised to 3/2 minus 1 is 1/2. And our g is the inside term, so we can see those 3's cancel, so our g is equal to u, the inside term, which is 5y squared plus 8. And the derivative of this, our u prime, is 10y. Thus, for the chain rule, it's f prime times g prime. So we know that this will be equal to 10y times 2, because 4 over 2 is 2 times u raised to the 1/2, and we know our u is 5y squared plus 8 raised to the 1/2. So when we simplify this, f prime times g prime is equal to 20y times 5y squared plus 8 raised to the 1/2. So our fy prime is equal to 20y 5y squared plus 8 raised to the 1/2. So now we have our f prime. So now we're going to square this. So f prime y squared is equal to 20y plus 5y plus 8 raised to the 1/2, and we're going to square that. And I use parentheses so we distribute the square to each term separately and we don't mess up. In doing so, we get 20y squared is 400y squared, 20 squared is 400, y squared is y squared, and then 5y squared plus 8 squared. We multiply the square root and the square, we get 5y squared plus 8 raised to the 1 power, or simply 5y squared plus 8. So now what we're going to do is we're going to distribute the 400y squared. And in doing so, 400 times 5 is 2000, y to the 4th power, because y squared times y squared. Since they have the same base, we can add the exponents. So it's y to the 4th power plus 400 times y squared times 8 is 3200 y squared. So now we're going to find the limits of integration, and in this case they were given to us. Again, my naming convention for limits. So the y bottom is equal to 0, the y top is equal to 1. And now we're going to set up the integral. So we know the formula for the arc length is y bottom to y top of 1 plus f prime y squared times dy. So now we'll recall our f prime y squared came out to be 200y squared plus 3200y squared, 2000y to the 4th power, plus 3200y squared. Thus our integral, we can set it up as the integral of 0 to 1 of 1 plus 2000y to the 4th power plus 3200y squared. And that's the answer, because we were only asked to set up the integral. We were not asked to solve it. Reason being because we actually can't solve this one. Why can't we solve it? Because this problem has, this inside the square root has imaginary roots. If we were to rewrite this in descending order and try to find the roots of this are imaginary, so we're not going to be able to solve this integral. We're only able to set it up. Anyways, I hope this video on arc length was helpful. If it was, feel free to like and subscribe, share, comment, leave feedback. Thank you for watching.